Okay, so if I have a slit like this and I send the wave front, okay, these are my wave front. You know what is mean by wave front?
Yeah, yeah. The peak or the
The peak?
trough. The crust of the trough. Wait, what's it called? What's this called? This point.
Which point?
This point.
Crest.
Yeah, that's the crust. That's the trough, right? Trough.
Actually, we have lots of wave, okay? If this is bulb,
Yeah.
okay, we have lots of wave moving like this. Okay. So this is my wavefront. These are my wavefront. We have lots of wave which is moving like this. So these are wavefront, okay? All
Yeah.
particles are moving like this, okay? So these are wavefront. So we have lots of wave moving in this direction. Okay, so when all that waves come over here, okay, then they will get a slit in front of them, and that slit that will be like, so here at the edge of the slit, okay, they will get bent, okay, and here you this will go like this will go like this.
It will become diffracted.
Yes,
Diffraction.
it will become reflected. So it will reflect like this.
No, it will be curved like this.
Yes, it will make curve like this. Actually, these light will get reflect, and these light will go straight. Actually, light waves over here will go straight. Waves over here will go straight, but waves over here will reflect like this. Waves over here will reflect like this. So I will get a wave front, and that wave front will be like this, like this. So this is known as diffraction. Okay. Actually, you will get this such like diffraction when you have a very small slit.
Oh, okay.
If you have such like, if you have a very small space between the two slits, so you will get this like this type of diffraction. Okay, now let's come toward the experiment, and that is the Mr. Young Double Slit Experiment. Okay, double slit. So I will use double. I will use double slits. Okay. Okay. Acha, Young was the physician. He used simple light. Let's say we are using candle. So candle have lots of other lights. Okay. So now the question is why he used two slits. So that is actually
Oh my gosh, I hate the Young Double Slit Experiment.
now the question is why he used two slits.
Oh, he used two slits because if you use so many slits, diffraction grating will occur. If you use two slits, diffraction grating will not occur.
And why he used slit over here?
So that the light can be diffracted.
Actually, at that time there was no laser. Nowadays we use laser.
The laser just goes through. The laser will go like that.
No, if we have laser, then we will not use this slit. We'll use only this. But because laser will give me monochromatic light. Monochromatic light means mono means one. Chromatic means color. One color light. It gives me one color light.
Oh,
You can say that one wavelength light, that light which have only one wavelength, red light which have one wavelength, that I think 495 nanometer or something like this. Okay, so he used this which have multiple wavelengths. Okay, at that time he has no laser, so that's why Young used this light. And when light come over here, so here we have lots of wavelength which will diffract like this. So red light will bend more, and then we have blue light, and similarly here we will have blue light like this, and red light will bend more over here. So this light will come over here and will reverse back, but blue light will go like this, and it will pass this slit. Okay, so that's why he used this slit just to get the monochromatic light. Okay, so here he got monochromatic light. Okay, then he places mirror in front of this light.
Why do you need monochromatic light for this experiment?
Actually, if I use this light, okay, then we did not study the interference through that light, because then the complexity will be high.
Yeah, it will be too much destructive interference.
Yeah. So that's why we use this. And also in maths, you study that we mostly use ideal cases, not discuss the practical case. Okay, so actually ideal case is easy to understand, and practical case, in practical you will contribute the pressure, that what will be the pressure, effect of pressure on,
my god,
what will be temperature of effect of temperature on this. So that's why we use ideal cases. And in ideal cases, we just take that if time is equal to 0, then what will happen, and if time is equal to infinity. So we just study the limitation, upper limitation, which is 0, and lower limitation, okay, infinity.
Yeah.
Okay, so in front of their two slits, he placed mirror at some distance d. So here he got lots of fringes, and the intensity of that fringes will get decreased like this.
What's the difference between diffraction grating and the Young Double Slit Experiment?
Actually, both are same, but in diffraction grating we use lots of slits. And what will be the effect of intensity in double slit?
Double splits, it will be like that.
And in single slit?
Same.
No, that will not be same.
Sorry, no, it will... I don't know, I forgot.
Yes, we are discussing all these things step by step, okay? So at the end of the class, you can ask any type of questions. Okay, so...
Wait, just tell me the intensity will be like that.
Yes, intensity will be like this.
And then double splits in the diffraction grating, it will be like that.
Yes, we will get like that because we have lots of slits. Here we have slits, here we have slits, so we will get same intensity overall on the mirror. But in Young Double Slit Experiment, we will get a high intensity at this point, only at this point. Okay, and our intensity will get decreased when we move away from the central fringes.
Same with diffraction grating.
No, same. But in diffraction grating, we have lots of slits. So if you use lots of slits, then you will get same bright light at all points. Actually, here you will get bright light, then the brightness will get decreased, then you will get dark light, then the brightness will increase, and here you will get again bright light. Similarly, you will dark, then bright, then dark, then bright.
Wait, show me on Google the intensity graph for Young Double Splits and the diffraction grating.
If you have one slit, then the intensity will be high, like this.
Oh,
and intensity will also increase. This will be higher than the double slit.
yeah.
Okay, and two slits you will get smaller width and smaller intensity in two slits.
Oh,
Okay, in three slits you will get like this, like these. Okay, so as I told you that here we will get same bright light, then the brightness will get decreased because here we have only these slits. But if you increase the slits, then here you will also get bright light, and here we will also get bright light. But in two slits we will get only bright light at the center.
oh. Why do you get bright light in diffractions?
Yes, I am discussing that on whiteboard. That the question is why I am getting bright light at at the center point.
Why are you getting bright light there in the second order and here,
Okay, here actually
here and here?
that is not too brighter. That will you will get bright light over here if you increase the number of slits.
Oh,
Actually, here light is covering same distance, and this light is also covering same distance. So that's why we get bright light over here.
I know the middle one. I'm talking about this one and this one. Why is it bright here and here?
Actually, it is bright.
Uh,
This distance, actually this distance, okay, and the light coming from this here, they are doing constructor interference. Okay, this distance will be equal to S. This central point and this from this slit central point, this distance will be equal to S, small s. This is B. So if you want to find the French width, okay, French width means okay, if this is French, so this width. So if you want to find the French width, so that will be, you can find that by using this formula, that W is equal to lambda D divided by S. Okay, this is French spacing,
yeah.
and this is W length, and this is this D, and this is slit. Okay, so at the center you will get bright light. Why you will get bright light? Because light coming from this slit cover equal distance as light coming from this distance. Okay, from this slits. Now you will also get bright light over here. Okay, because you will also get bright light because the light coming from here, and this distance S1, distance line 1 is not equal to line 2. Okay, line 1 is not equal to line 2. But if you measure it through ruler, okay, if you measure it through ruler, and let's say that is 5 centimeter, and you will count the 5 centimeter over here, and let's say up to this you get 5 centimeter. So this is the phase difference. Okay, this line, this extra distance is creating a phase difference.
Yeah.
And if that is equal to lambda, wavelength of light, or 2 lambda or 3 lambda, then you will get constructor interference over here, because these two lights will get superimposed. You will get constructor interference over here, and you will get bright light. But the intensity of that bright light will be smaller, because this light is covering huge distance, and this light is covering small distance, 5 centimeter.
Yeah.
Okay, so that's why you will get less bright light over here. But at the center, both lights are covering small distance, okay, and equal distance. So that's why you will get a bright light over here, and the intensity of that bright light will be higher.
Yeah, the brightness, the constructive interference will produce bright here, but the intensity of this brightness will be less than the brightness over here.
Yeah,
the photon.
yes. Okay, so if MCQs come like this, that if I increase the fringe, if I increase the distance between the slats, okay, then what will be its effect on the fringe width?
if you increase the slit, the fringe width will decrease.
Will decrease. It have an inverse relation with this, okay, and it have direct relation with D, and it also have direct relation with lambda, okay. This, and let's say this is the central fringe, okay. Here you have another fringes are like this, bright, dark. This is dark, okay. This is bright, dark, bright, dark. So this is actually I am discussing mirror, okay. And let's say this is the intensity, this, and let's say I'm using double slit. So in double slit, I will get, this is the central, so I will get the intensity will be higher.
Oh.
So here you will get dark light.
I have a question. Does the width decrease? This is the width. Does it decrease?
No, it remains same.
Okay.
And that will depend on what?
If it's diffraction grating, the width will change. If it's double split, it will stay the same.
No, we will discuss that later on. And that will depend on what? This will depend on what?
Oh, I don't know.
Not this. That is W. That will depend on the wavelength of light. That will depend on the distance between the mirror and slit. That will depend on the distance between the slits.
Yeah.
Okay, if I use single slit,
then the central fringe will have a greater width.
okay, greater width, and
I don't know why though. I just remember I saw it in some website. I don't know why. Wait, if it's single slit, no interference will occur. Then why is there constructive interference?
actually if you have one width, okay, then light will go over like this. And it will have some bend little bit.
So no interference will occur.
Yeah, so no interference will occur and you will get the light over here. But if you have another slit, then you will get interference occur, and here you will get
brightness.
bright, dark, bright, dark, bright, dark.
So in single slit, how will it look?
Okay, in single slit, the intensity will, let's say this is the central, okay? So the intensity...
Wait, what? Is this destructive interference? This...
Actually, you will get high intense light and the width will be high, and then you will get like this.
What is x-axis?
X-axis is the mirror. Here you will get no bright light.
Yeah, you won't get any dark light. You will only get bright light.
Yeah, only get bright light, and this light is actually, the light is bending over here.
Oh.
Got it? And here there is no bending, so it will pass along the straight line, and here you will get a bright light. Then the brightness will get decreased gradually, and here you will get dark light. So here you will get dark light, dark, and here you will have a high brightness. This brightness will be greater than this brightness. Okay.
Oh, because here, is it like this, like that, and then like that?
Yes. It is like this. And if this is your slit.
I'm drawing it from here.
Yeah, this is your slit. So light are passing like this, and here light will get bent.
Oh, that makes so much sense. Now I understand it.
Okay, and central very bright. Okay, and the width will be the double of the fringes which we get over here. Okay, that will be double.
Why?
W. Actually, we are using single slit. Okay, if I use another slit over here, then there will be some sort of interference occur with this.
Yeah, you're right.